If it's that leggy already, that's a bad sign. Okay. Let's talk about transformations for a minute. So we're going to talk about all the transformations that we've learned because we've learned a lot of them. You can now put them all together. That's what we're about to do. Now, I've been writing. Thank you. You gotta stop talking. I've been writing them like this: y equals a f, and then b, and then x minus h, and then plus k. Agreed? And that's how we've been talking about them. It's easiest way for us to like add and multiply and actually put things into equations. That's the nice part about having it this way. Technically, you could rearrange these. And some of you are starting to notice that on the answers in your book. So, just to let you know, Canago Pizza. Yeah, Flex is about that. Flex about that. You could rewrite this. And so some of you are like, I don't know what's going on. I'm getting questions wrong. And you're not getting questions wrong. It's just that the answer looks different than the answer you're getting because you're writing your answer like this. What? I was going to say something, and then I was like, I don't need to say that. Okay. All right. You're like, never mind. I'm not going to say that. Okay, so if I had that, you could rearrange it. And what you could rearrange and what you could move is you could move the k value and you could move the a value. So technically, you could like subtract this k value and write it on the other side of the equation. Right? So technically, instead of having my vertical translations on the right side, I could have it on the left side of the equal sign like this. It means the same thing, and it's still a vertical translation. It's just been moved to the other side of the equation. And I can do the same thing with the a value. I could move the a value from the right-hand side where the function is to the left-hand side where the a is if I divided a to the other side. When you divide a to the other side, you would be doing it to like this thing in brackets, and it would look like this, 1 over a. Right? That's the same thing as dividing by a is multiplied by 1 over a. Why can't you just divide it on this side? Because then k wouldn't be k anymore. K would become k divided by a, right? And it wouldn't be what you want it to be anymore. But now k is becoming k times 1 divided by a. If you were to multiply it in, but we're not multiplying it in. We're leaving it like this. Okay. So technically, you could rewrite your transformations in that form, but everything still means the same thing. The a value is still a vertical stretch. The k value is still a vertical translation. Like nothing is changing. It's just moving from one side to the other. Stretches on one side and translations on the other? Yes. Is it like split up like that? Yeah, that's the benefit of this. So the benefit of having it written like this is that now this is my vertical stuff. These are things that affect your y value. These are my horizontal things that affect my x value. So that's the benefit of having it in this form, is that it kind of separates it. Like a and k affect y, b and h affect x. So it's nice when it's in that mode. Right? The downside is if I said, hey, transform this, I don't know how to like transform a function when it looks like this. I would have to move things over. So I'm like, oh, okay, I'm adding 6 to the function, or I'm multiplying the function by 3. Right? Like it's a little bit messier when it comes to that world. Yep.
Wait, and your negatives on your reflections go to your A and your B?
Yes. Yeah. The other benefit of this mode, or I should call it mode like it's a game. The different benefits of this form and having things pushed to the other side of the equation is that now everything's opposite. So remember how we used to talk about like, if it says -3, that actually means 3 to the right instead of 3 to the left? Because we've moved things over, now it works for both sides that it's opposite. So if this was y minus 5, that would actually mean 5 up, not 5 down. So it makes everything through that lens of like opposite, which may be a benefit, or maybe that makes it more confusing. The big thing is recognizing A, B, H, and K, no matter where they're located, are doing the same thing. We're still talking vertical and horizontal translations. We're still talking vertical and horizontal stretches. We're still talking about reflections about the X and the Y axis. Okay? Like none of that stuff has changed. On this slide, we're going to write what each one of those letters mean. So let's start with A. Your A value. A is a vertical stretch. Look at that sentence. A is A. A is a vertical stretch. It's not good enough to just say it's a vertical stretch. About the x-axis, right? You're stretching away from the x-axis. Good. A is a vertical stretch about the x-axis. Yeah, Caden.
And it's the x-axis because it's affecting y?
Yes, because you're moving away from the, like if you think about it like this, you're affecting the y value of a point. So like if I was there, pretend that that y value is at 2. If I vertically stretched it by 2, the y value would become 4. Agreed? And the y value changed. But I stretched away from the x-axis. So that's why I say about the x-axis. Because that's what I'm moving away from. My distance to the y-axis does not change. It's still the same distance side to side. Perfect. A does something else too. If A is less than 0, I'm going to put it in brackets. That means negative. If A is less than 0, if A is negative, what does that do? It does a reflection. There is a reflection. And what are you reflecting over? That's inverse, yeah. The x-axis. A reflection about the x-axis. Right? The y value goes from positive to negative, meaning you've gone from the other side of the x-axis. But the y values are changing. That's how what our b value. Your b value is another stretch. What type of stretch is it? Horizontal. And what's it stretching away from? The y-axis. Perfect. So B is a horizontal stretch. And you do have to say what it's stretching away from. Okay, so it's a horizontal stretch about the y-axis. Yeah, and you could even say by a factor of 1 over b. Like if I was to ask you in a statement, then you'd be like, it's stretched by a factor of, right? But for this purpose, I'm just going to leave it like that without talking about the factor part. What else could the B value do? Yeah, it could do a reflection. If B was negative, which means less than 0, right? It's pretty rare that there's a question that says, oh, it's negative. That doesn't say that. It'll say B is less than 0. So if B is less than 0, again, that means negative. There is a reflection. And what are you reflecting about? Yeah, a reflection about the y-axis. I'm writing very slow because my computer cannot handle this. So about the y-axis. Nobody was going to mention the fact that I just said the axis on the question above. X-axis.
I mean, you weren't wrong.
I wasn't wrong. It was a axis. All right. H. What does your H value do? Beautiful. It is a horizontal translation. I'm going to put in brackets. That means it moves left or right. Is I gotta go quotations. H. I don't know why they're all capitals. They should be lowercase. H is horizontal. Horizontal in brackets. I'm putting left, right. Translation. Translation means like a shift, right? So if you want to even put shift in there in brackets too, feel free. Last one, K. K would be a vertical translation. Oh, I try to go fast and it gets really bad. K is a vertical. That means up, down. It'll come back. K is a vertical up, down translation. It'll reset. It'll come back.
Can we refresh negative and positive? H and K values?
Yeah, and so like it's tricky like the way it looks, right? We'll get to questions where it's like, what is the K value here? Right? So when K is positive, it goes up, down. When H is positive, or sorry, when K is positive, it goes up. When H is positive, it goes right. But the problem is in your function notation, it looks like minus H. Right? So we will look at a bunch of questions. I think we have a whole whack of them coming where we do exactly what you just asked about. And that is the refresher that we kind of need, right?
What is this the order that we go in?
No. Technically, yes, but that's not what I mean. That's how I didn't do that on purpose. Like I'm not trying to talk about them in order. Cool. One more thing I want to note here, and we talked about it a little bit when we were learning them, is you don't always have to reflect and translate entire equations and graphs. You could do it to just points, right? So when you're talking about just a point, these two values, A and K, they affect the Y value. And I think that's important just to make note of. Like, if I do a vertical stretch only the y value should be changing. That means if I had a point, the x would stay the same. The y value would stretch. Same with if I did a vertical translation, right? If I take a point and I move it up or down, the x doesn't change. It's just the y value that changes. So this is a y value. The same goes for horizontal things. So when I look at B and H, if I'm stretching something horizontally, it doesn't go up or down. It goes left or right? It's just stretching left or right, which means it's only affecting the x values of your points. And the h value is only affecting x values as well. The reason that's useful is you get a lot of questions where it's like, hey, this point is on the original graph, and it goes through this transformation. You just have to move that point. And I do that point like x values with x values, y values with y values. Go on, now let's get to some questions. We got a whole whack of them coming. So when you do multiple, might be the weirdest thing I've ever seen in class. 8 years in, but you might have just done it. I'm not going to say what she did. We'll keep that between Maddie Kennedy and myself, and anybody else who witnessed that. I don't know. That was strange. You read? My bad for calling you out in front of everyone for being weird. I didn't tell them what you did. Now it's a mystery. Now they're all wondering. They're all like, "Oh God, what did she do?" Sorry, Kennedy. That's like number like one of. I didn't hear what Cicely said. I'm scared though now. It wasn't even that. It wasn't bad. It was just interesting. It's our secret.
You can't keep giving us tidbits of information.
I'm sorry, Kennedy. I apologize. Okay. No, the only person I'm sorry to is Kennedy. Kennedy should stick together, and I just, from Kennedy to Kennedy, I messed that up. Now that we're going to put these things all together, so we're going to do a whole whack of transformations at once. The order in which you do transformations matters. Okay, so if I took a point and I start moving it, I'm reflecting it, and I'm stretching it, and then I'm shifting it, you have to do things in the right order. Go with bed mass, right? So with bed mass, you have to do multiplication before addition and subtraction, right? So that means when you do your transformations, you need to do your multiplication before your addition and subtraction. Multiplication was stretches and reflections. Addition and subtraction was translations. So you must do your transformations in this order. You stretch, you reflect, you translate. Okay? Stretch and reflect can be reversed because they're both multiplication. Okay? I just will always go stretch, then reflect, then translate. You technically could go reflect, then stretch, then translate, and it'd be fine. As long as you're doing it in the order of multiplication first. Multiplication was our stretches. Then my horizontal, vertical translations, which is my adding and subtracting. Let's look at this one. So list the transformations which are applied to y equals f of x to become y equals, and then that whole shebang there. Okay. Yep. That's an inverse. If you're given a point on a graph, I'm taking that choice. You're multiplying it by a negative. Yes. A negative will flip it to the other side of the axis. The x and y swap is inversing, which is a reflection about my diagonal line. Okay. Yes. So that looks like this. But why on this one? So like this. This is your regular thing, right? Y goes like, you're discussing inverses.
You're disgusting. Inverses. Wait, would you flip?
Right? That's when you would take a point and flip x and y. And that's a reflection about x and y. If you inverse something, I don't think you're going to inverse it then translate it. You will just inverse it.
Do you do your vertical stretch first?
That won't matter. No. Does that answer your question, Kevin?
I think so.
A little bit. You're like, no.
I just why did it from this one it's reflected would be inverse.
Where'd I put that?
Like on the last question we just did, is it because it's
Up
in the
right
line
here?
y and x? No, the one before that. Okay, the one before that actually.
Yeah, that's
That one, yeah.
this one.
Because it says the x.
Because it says that it reflected about the line y equals x. That's why it told me it was an inverse. Yes. Okay. Okay. Writing out transformations. You must write them properly. We have to use the proper terminology. Okay, you can't just be saying like it goes up, it goes down. That's not going to work. So let's start with our stretches and reflections. Yeah. Yes, you may. I'm just going to start by dissecting this a value. If I wanted to describe what that 4 is doing, it would be a vertical stretch by a factor
Did you do the about and then the factor or the factor?
vertical stretch about the x-axis by a factor of 4, by a factor of 4 about the x-axis. Wouldn't matter. You could reverse it, it would still work. A vertical stretch by a factor of 4 about the x-axis. You must use that terminology. So what I'm saying is it's vertically stretched, so it's doing this. Then I have to say by how much. So by a factor of 4 means I'm multiplying everything by 4. And then I have to say what I'm stretching away from. So about the x-axis. Okay? A vertical stretch by a factor of 4 about the x-axis. That's what the a value is doing. Yeah.
What is that one? The B value. Does that one switch the positive to negative?
Not positive, negative.
But it flips.
It flips the
So
factor.
I was curious because inside the brackets, like that positive 3 would be like it's a negative 3.
Yes. So it's actually going left, not right. Yeah.
So, but it wouldn't switch on the one.
Right. Yes. Yeah. Yeah. Okay. So we're looking at the B value. I'll do it in blue. That's doing 2 things. What are the 2 things that negative 1 over 2 is doing, Maddie?
Stretching and reflecting is negative.
Yes, because it's negative, it's doing a reflection. So you'd have to state that. And it's also doing a stretch. The order in which you write that does not matter. Okay, so if you want to write the stretch first, that's fine. If you want to write the reflection first, that's fine too. So I'm going to say that it is a horizontal stretch. That's me saying I'm stretching it left or right. By a factor of 2.
Wouldn't
Rem-
be
Yeah,
negative
wouldn't it
2?
be negative 2? You just told me that it doesn't switch.
Put the negative.
I see what you're saying. The negative is what's reflecting it. So because I'm going to state that after.
So the negative isn't included.
I'm not including it in my factor multiplication.
Take it out.
Yes. So I would say that it's multiplying by the stretch is by 2. Then it's a reflection, which is what moves it. So it's a stretch by a factor of 2 about the y-axis. And then I'm going to write a different transformation for that negative. right? Now I'm going to say that it is a reflection about the y-axis, and that covers the negative part. So we have a vertical stretch by a factor of 4 about the x-axis. We have a horizontal stretch by a factor of 2 about the y-axis. We have a reflection about the y-axis. That covers your negative.
Don't you have to say by what factor though?
A reflection doesn't have a factor.
It doesn't?
Like if I reflect something, if it was at 5, now it's at negative 5.
Oh.
Right? There's no factor
I
to
guess
it.
that was cursed.
Like I've.
Did I say yeah? Sorry. Like you did do a fact. Like it's hard because what you've done is you've multiplied by -2. Like you did have a factor.
If anyone else wants to speak up, I'm here embarrassing people today. That's 2. Anybody else want it? You know, come get some. Ask an honest question. I'll get you. Holy smokes! This is a lesson on proper teacher practices. I did not mean, yeah, that was stupid. I just. Jeez. Yeah, I know. This is going on my rate my professor, rate my teacher. Jeez. I know. I did. Oh, jeez, Emily, no. I had a dream last night that Mr. Garrow fired me. Maybe it's coming. You know, there's a. Holy smokes. Sorry, Em. The hard part is you have, if you had a point, you did multiply the x value by -2, right? So, it is a little mix up of, what's the factor and what's the reflection. Like that.
Oh, you're multiplying it by the negative then?
You are, which is why I'm saying it's not a stupid question, because you are multiplying by -2.
Well, not -2, but negative.
Yeah. Yes. Yeah, it's like a 2 and a -1. I've broken those two things up. Yeah. It's a reflection. Yeah. Yeah. Yeah.
So is the reflection just the negative then, or is it the -1? Because if it's gonna flip,
It's just the negative. It's just the negative. Yeah. Imagine it's like this. You know how we can rewrite fractions like that, right? Imagine it's like that. So I could take a fraction and I could move it from the numerator to up front. There's my reflection, there's my stretch. So maybe that helps see that you've broken them apart. Yeah.
Wait, so if the 4 up front has negatives part of it, you do the same.
Yeah. So had this 4 been -4, I would have had a stretch of 4 and then a reflection about the x-axis. Yes. And I'm viewing it as 2 separate transformations.
For the reflection, you don't have to write horizontal.
I don't think so. I think by saying what you reflected about by.
If you did,
I'll look into that. I don't think so. Okay, there's 2 more here. We have this value, the +3. That's inside the brackets. That's my h value. Guys. So to properly write that h value, you have a horizontal translation. Right? That h value moves things left or right. Perfect. You have a horizontal translation, 3 units left. The actual h value there is -3. right? Because in my formula, it's minus h. So minus -3 is why it looks like it's +3. But the h value is -3, so it went 3 units left. Yep.
Can you say 3 units about the y-axis?
No, no, it left. Yeah, I see what you're saying, but you don't. By saying about the y-axis, about is like getting away from. Yeah, no, yeah, no, I don't think it would work because even then, if I said 3 units, are you getting closer to or further away from the y-axis? It means multiplied by, so it's like. Because you could stretch and get closer to the y-axis if you stretch by a decimal. Yeah.
Could you say like left 3 units instead of?
Horizontal translation, left 3 units. Yeah. Yeah, I'd mark it. Yeah, that's right. You've indicated how far and which direction. That's the key, right? So that's important. The last one is this -9. That's a vertical translation. Nine units down.
If you're drawing the graph for your like b value, do you use like the 1 over like do
You would multiply by 2. Yeah. Only in function notation is it opposite. It's the only spot where it looks wrong. Everywhere else, when we apply it, we're applying it by 2 at all times. You must use this terminology. They are extremely picky on it. They're picky enough to the point where, like in your answer key to a lot of things, instead of vertical translation, you will see VT. If you were to write that on your diploma, it would be wrong, right? You need to put a vertical translation. No questions about it. They are strict. Because your diploma is going to be strict like that, I will mark your test like that. So you must use proper terminology and no abbreviations. Yeah, no vert trans. No, vertical translation, right? Like don't go slow on it. All right. I want you to look at that question. List the transformations applied to become that. Do you feel like you could do it right now? Okay, try it. I'm going to write my answer up on the board. I want you to write all the transformations that happen here. I'll give you a hint. There's 5 transformations there. So you need 5 statements. In this one, because I know like most of you guys look like you're done or getting close to done. Same thing. That's okay. In and out about is okay. I do believe in your practice booklets, I think in your practice booklets, the answers are typically written like this. It's like horizontal stretch with just HS. And that's what it means. When you are answering on a test, don't shorthand things. That's what I'm trying to get at. Okay, so like if you were on a written response test, you put HS of, no, it's going to be wrong. Yeah.
I just wanted to clarify, so when it is like for HS by a half, do you multiply the x, the y value by 2 or a half?
Half. But we are talking about x values.
No, I know, I'm just clarifying for the b value.
For the b value, you are multiplying the x values.
Yes.
Yes, by a half.
Oh, yeah, but whatever.
Yeah. And that is important. Like that's what we talked about. That's what she asked as well. So when am I multiplying by 2? When am I multiplying by a half?
I will wait till he does it.
In function notation, that is the only spot where it looks different.
Oh, so you do the opposite.
Everything else is going to be by 1/2. So when I talk about it as 1/2. When I multiply by 1/2. Just here, it's 2. Before I move forward, is there any questions about that log thing? Yeah.
So now that you could graph this technically, just take a while. Let's go through all the steps that you do it all.
Yep. Yeah, we could graph that. We will. Yeah, we're gonna do questions like this where we do graph them and we move on.
The function can change to anything really, but doesn't change like when you're doing this kind of stuff.
Yeah, like the function could be anything. Yeah.
Unless you put it in your calculator, you still don't know what it looks like originally. So you gotta look at it.
Yes. Yeah. Okay, let's move forward. We gotta get this one done and then we'll go. You're fine. Okay, it says consider the function y equals f of x. In each case, the function will undergo a transformation and can be written in the form, and then there's our big transformation form, right? A, B, H, Q are all in there. We do not know what f of x is. I have no idea what the function is. It could be a log function, exponential function, linear function, quad function. I don't know what this is. We're just doing transformations to it. So we are going to write it in function form still. First one, a stretch by a factor of 3 about the y-axis. Okay, if I'm stretching away from the y-axis, so here's my y-axis, I'm stretching away from it. That is a horizontal stretch. Agreed? This is your b value. Right? That's what it's talking about. A vertical translation, 6 units up. Okay, so a vertical translation, that is talking about your d value. Oh, geez, Louise, that's a throwback to Math 1. That's your k value. Yeah, don't worry about it. Why I called it d. There you go. Okay. Now let's actually try to write it into an equation. There's no a, there's no h. So it should look like this. Y equals. There's no a value. F. There is a b value here. We multiplied by a factor of 3. When we put this into function notation, it goes to 1 over 3. Right? Function notation, it looks different. 1 over 3x. And then I do my k value. 6 up means plus 6. That would be my transformed function. Next one, a vertical stretch by a factor of 2 about the x-axis. If they hadn't said vertical, I would have known it was vertical because it said about the x-axis, right? So x-axis is here. I'm stretching away from it. That's vertical. That means this is discussing your a value. And then translated 5 units up. 5 units left. That would be an h value. And 2 units up. That is talking about a k value. When these things go into function notation, a actually goes in the way it looks. So this would be y equals 2 then f. There was no b value, so there's no stretch. It would be x plus 5. Okay, my h value is negative 5. But if I do minus -5, it makes it +5. Close the bracket. Do your vertical translation, +2. Gorgeous. Last one. We have a horizontal stretch of 4. Horizontal is talking about B value. A vertical stretch of 2. That's talking about your A value. A reflection in the y-axis. Okay, so y-axis is like this. I'm reflecting to the other side of it. That would be my x values changing. That means this is talking about my B value. And translated 10 units down. Down is going to be my K value. If I was to write this all in at once, this would be y equals my A value is 2 F of bracket. My B value is going to be negative from the reflection. 1/4 because of the stretch. X, close the bracket, -10. Done. Tomorrow's quiz